Hello world, good evening Sheffield. I am super excited to be with you tonight. I think around the Corona timeframe, this was the start of my speaking career, more or less. And I think in that Corona timeframe, I think I did at .NET Chef one or at least one, I think two online talks. So I really appreciated that opportunity that kind of kickstarted me. And now I'm super happy to be finally here in person with you, my first time in Sheffield. Thank you very much for joining me here, and thank you very much for the opportunity, Kevin, and to the organizer team. Welcome to Null and Void, everything about nothing in .NET. We will mainly talk about what was added in C# 8, the nullable reference types feature, which basically enables us to have a question mark next to reference types. But there is a whole lot of a dimension to it, and we will dive deep also how the compiler team has implemented this feature. So you could also inspect these for advanced use cases at runtime, or maybe also at compile time with writing your own compiler plugins. There will be a little bit about Void, and we'll also chat about how we could transition existing code bases that are not null aware just yet, because the feature was introduced in C# 8. All the projects did not have this feature enabled. It's an opt-in feature because it may be a breaking change when it comes to the warnings, and if you have warnings as errors that become emitted. And we'll also at the end round things off with taking a look at things that how we could avoid null in the first place. My name is Stefan Pölz. I'm from Austria. I did bring some Viennese wafers for a dessert to the pizza, but we talked about it. They may be addictive, so heed the warning. I'm a Microsoft MVP, a JetBrains community contributor, and also a co-organizer of the .NET meetup that we host in Vienna. I listed on my GitHub page my socials. If you have later on any questions about null, nothing that I could answer later on, then this QR code links to my GitHub account if you have any questions later on. But yeah, we will definitely have a bit of a QA if I was not able to answer everything right away. All right, let's jump into the world of nothing. So I'm having here some good old C# code, having a local variable of type string, and it says hello.NET Chef, and then we print this to the console. Let's see if that works. Wonderful. Now I would like to get the length of the string. Let's see how many characters does this string contain. It contains 19. In string, if we take a look at the implementation of string, we will see this is implemented as a class. Classes are reference types, and reference types, well, we could have a reference to nothing. If we do that, the console.writeLine, well, will not print anything, but when we try to dereference this null reference, we will run into the dreaded null reference exception, the famous $1 billion mistake. What we see here, I do get a couple of squigglies here already. When I write null here, there is a squiggly, and when we dereference here via the dot, when we dot into the text variable of type string, get a hold of the length property, we also get a squiggly. Perhaps you remember, well, not remember, but in C# 1, we could always have nullable value types. For example, let's have an int number, 2025. Let's print that number, and maybe let's invoke a member of this number. Let's do a toString, and we will get twice 2025 to the console. Now what we could do since C# 1 is add a question mark there, which now changes this from a value type to a nullable value type. So we could say 2025, but we can also say null. What happens now? Well, nothing. If we go back to 2025, the first toString will indeed print 2025. And where is now this toString coming from? Is this a toString from an int, or this is a toString from another type? We see we are not, when I F12 into the toString that I call off of int question mark, we now see this is no longer int. This is actually of type nullable. So in the system namespace, there is a class, a struct that's nullable of t, where the t is constrained to other structs. And this is really what happens when we change a value type to a nullable value type. It's not only some syntactic sugar, it changes the semantics of this type. This is no longer an int, this is actually a nullable of int. Whether we write it like this or int question mark, that really is the same thing. This is what the compiler turns it into. The thing about value types, so we saw int question mark, that's the nullable type, which is again a struct. Value types, hence the name, cannot be null. They always carry a value. So when we say null here, this still isn't really null. I can still call toString without running into any null reference exceptions. Because what's actually happening is this value is now encapsulated in this nullable of t, where we now have a dot value property. If we happen to call the getter of this, well, it is a get-only property, but if we invoke this get-only property, we get an invalid operation exception. This is not a null reference exception, because although it's a nullable value type, it's still a value type, and the value type can never be null. And the implementation of this nullable value type is, we get this property, we first check, does it have a value? And if it does not have a value, we throw an invalid operation exception. If it has a value, we just return it. So the pattern usually with nullable value types is, we could say if this number of type nullable of int, does it have a value? And if it does, then we allow to print it. So if I run this, now in this case, nothing would happen. So with nullable value types, we see there is at runtime a different type in place. Now let's jump back to the string. This is now the C#8 feature. We now also have nullable reference types. They didn't exist before C#8. But how does it work with nullable reference types? I add the question mark. There is no dot value. There is also no dot has value. The thing about nullable reference types is they do not change the type. This is still a string. At runtime, it's a string. There are just some compiler attributes, some annotations on top that at compile time, the compiler could now understand, this may be null. Perhaps you would like to do a null check. For example, when I call into the length property of string, we now get a warning here saying dereference of a possibly null reference. Because we annotated it with a question mark, we know that nullable reference type, this may be null. What if it isn't null? Well, the compiler is smart enough to understand, well, we actually assigned it up here. But still, we can now remove this question mark. And now we said, okay, this is not null, non-nullable. So we do not get a warning here. We do not need to do an if check. If I were to assign null to a non-nullable reference type, we get the warning when we try to assign null. It says converting the null literal or possibly null value into a non-nullable value, non-nullable type. This could now cause, it's a warning, this could cause at runtime cause the null reference exception. Likewise, let's say I have a string, a nullable string, and I were to try to assign a nullable string to a non-nullable string, we also get a warning here, because we could possibly assign null to something that per contract we said is not null. The other way, however, is safe. If we had a non-nullable string, we of course can assign that without any warning to a nullable string. because, well, the nullable says it may be null, not necessarily that it is null. Jumping back to my notes, yes. So how can we now avoid those nasty null reference exceptions? Let's say we have a null here or something that may be null. And we want to get the length of the string. We get the warning because we try to dereference something that may be null. We just need to do a null check around it. Oops. So we can say if text is not either is not null, or via C#9 pattern matching is not null. And now it's safe to dereference this nullable string because the compiler does a static flow analysis and understands that in the scope of this if, text is not null. Outside of the scope of this if, text may be null. So if we were to try to dereference down here, we get the warning here again, because in this context, it could be null. This is the static flow analysis the compiler does on nullable reference types. But this really is a compiler feature. This doesn't have any, at runtime, there is no different type that it gets compiled to. There is no additional code that's executed. There's exclusively a runtime feature. Now, how does this feature look under the hood? I have here a class that has a couple of methods where we take, in method 1, we take a nullable string. So that's a nullable reference type. In method 2, we take a non-nullable string. And then as a second argument, a nullable string. And the third one, we have 4 variants of arrays. The first one is an array where the array itself is not null and its elements are not null. The second one, here we say if the question mark comes after the array, that says the array may be null, but the strings, the elements contained in that array may not be null. So if we have 7 strings in that array, there is non-nullable strings, or there should be non-nullable strings in that array. This also goes the other way around, where we have, in this case, the array is not null, but the items in that array may be null. And we can have both as well, where both the array may be null and each of its elements may be null too. If we grab this code and put this into sharplab.io, we can now compile the code to IL and decompile it back to C#, which is a way to get rid of a lot of syntactic sugar. Because once you go to IL, once you go to metadata, you can't, with full fidelity, return to the original C# code. You can return to it semantically, but not necessarily syntactically. So how does this feature really work? So as we mentioned, there is no separate type for nullable reference types. How does the compiler do it? With attributes. We get the nullable context and the nullable attributes. They, in earlier versions of the compiler, they are emitted by the compiler. So, for example, if you target net standard 2.0 with a compiler that does support C#8, so at least .NET Core 3, what's the least supported version? I guess .NET 8. If you have a .NET SDK and compile a .NET Standard project, those attributes get emitted for you. In newer versions of the BCL, they already come in box, so that the compiler doesn't need to do additional work. But we cannot use these attributes ourselves. They are illegal to write yourself. Compiler would say, not only is it not found, but if we were, I guess, yeah, in this case they are not available, but if they were available, it's still illegal to use them yourself. They are emitted by the compiler. And the compiler does a bit some optimizations there. So we have the nullable context attribute and the nullable attribute. In this case, for this string, we have a 2. There is 3 numbers, or 3 numbers. If it's a 1, that means oblivious. So this type was compiled without having nullable annotations enabled. So maybe with C# 7.3 or earlier, or you have not opted in to these features because it's an opt-in. 1 means not annotated. so there is no question mark, so it's a non-nullable reference type. 2 means annotated. There is a question mark, so that's a nullable reference type. We see here there is no question, there is a 2 here, that means it is annotated, so there is the question mark, and we see that in source as well. Now this one doesn't have an attribute. There is no attribute on the parameter itself, also not on the method, so we then jump to the closest context, which is this one. This is now a 1, which means it is not annotated. So no question mark, and indeed we don't have a question mark here. But the second one has nullable 2, that means annotated, there is a question mark, and indeed this is how it is. And it's similar for the arrays as well, but with arrays we really have 2 possible points of annotation, the array and the elements. For example, in the last one, if it just says nullable 2, that means both the array but also the elements are nullable. In this case, for the third one, we have a 1 and a 2. That means the array is not annotated, but the elements are. And indeed, when we jump over to the source, the array is not annotated, that's not null, but the elements, they are. Now, those are rather complex rules, and you can now utilize these rules to build your own toolings. For example, with .NET 9 and F#9 now also supports nullable reference types. F# is built to avoid null in the first place, so if you build a pure F# application, you never need null. But if you interop with other languages, such as C#, which has heavy use of null, or you go via JavaScript, which even has 2 nulls, it's a null and an undefined. When you go cross languages, now F# also supports nullable reference types, and for the C# interop, they now also consume and analyze those attributes to import into their ecosystem and allow a nice flow of control between the languages. Now, if you were, for example, Entity Framework, and you would like to use those nullable annotations to, for example, emit not null or null annotations for your SQL statements, you could also utilize these via reflection. I have a small example here. For example, I believe I used this class, yes, where we use the same class. Oops. And when we run this, this should print the same information as we saw via SharpLab. Jump to the class. Let's see if it does the correct thing. Let's inspect maybe the third array here. And it says it's a not null array of nullable strings. So does that correctly. But how did we do this here? When we jump into the implementation, reading those attributes manually is possible, but it's very tedious and also very error prone. In newer versions of .NET, there is a type called the nullability info context. You can create yourself this nullability info context, and with that, then create so-called nullability infos off of it. Via reflection, for example, of these methods, I extract all the parameter infos, then create nullability infos via that context. And now this nullability info contains the information, is this null or is this not null? For example, we have the read state, which is, in case of an array, it would be the array itself. And if this thing is an array, we also have the element type of this array, and we check the read state. We see there is a read state and a write state. We'll come to that later, why there is 2 different states of nullability on for example, this parameter info. And these states are now nullability info states. And again, they have the very similar structure where the first one is unknown. That means it wasn't compiled with any of these attributes. It wasn't compiled with the feature enabled. We have not null. That means it is not annotated. There is no question mark. We have nullable. It is annotated. There is a question mark. Now I mentioned a couple of times that that's an opt-in feature. When you create via the command line, when we do a .NET new class lib or a .NET new console or pretty much any template, you will get, if it's an executable, we get the exe, we get the target framework, and in all the modern templates, we also get this nullable enable. This is the switch where we opt in to this feature. And we now have nullable reference types enabled. If we were to disable them or not have this in the first place, if we were now to write string question mark, we get a warning at the question mark saying that we are not in a context that has nullable annotations. Now, we can also enable this feature on a source level via this preprocessor directives #nullable. When we enable it on a project level, if we have enabled here, that means we now enable both the nullable annotations and nullable warnings for the entire project. But if I were to enable this on an existing project where I have a lot of code, now I get warnings all over the place. This may be a bit overwhelming, so I can focus enabling maybe step by step on smaller scopes. Let's see this example. I could, at the top, currently for the entire project, nullable reference types is enabled. I could say nullable disable. Non-nullable reference types are disabled, and I get the warning down here because I'm using the question mark, but they have the feature nullable reference types disabled. Now I mentioned there is warnings and annotations. We can disable them individually of each other. I could, for example, disable nullable warnings here. The annotations, however, are actually enabled. I make it explicit, enable nullable annotations. When we have nullable annotations, that means we can write question marks. So that the compiler is now emitting these attributes. So that's on the production side of things. The warnings, they are on the consumption side of things. So if I were to, since I now disabled nullable warnings in this context, if I were to write a string question mark, null, and then do a dot length here, I'm getting a warning here, but this is, I believe, the warning from writer. This is not the warning from the SDK, because we actually have those warnings disabled. So if you do a .NET build, you won't get this warning. And especially, maybe you do something like treat warnings as errors, true. Now, although I enabled treat warnings as errors, this is not an error because, yeah, this is something that writer shows. This is, if I were a .NET build via the SDK, this would not produce any warning because we disabled the warnings. So you could, for some context, only enable annotations, but disable the warnings, and then so that you start annotating your types with question marks where you say this is optional. And likewise, later then maybe enable the annotation, the warnings too, and then get rid of the nullable warnings. In pretty much every project that I work in, we have treat warnings as errors when it comes, well, generally enabled. If you would like to only treat all the nullable warnings as errors, there's a bit of a group. We could write nullable here as well. And this is now only treating nullable warnings. There is like 8 or 10 diagnostics. So that's those compiler warnings that produce the squiggles in the SDK that are related, or maybe even more, 20 something. There's quite a bit. But this is in this group now treats all of the nullable warnings as errors. And this is now really a benefit because if you have in your project at compile time already see that you are not null checking something that may be null, or vice versa, you are assigning null to something that you annotated as not be null, you already get an error. So we're fixing potential null reference exceptions before they even occur at runtime. Now, talking about runtime and compile time, we can also use this feature on a compile time level. This is from an older project where we used data contracts heavily. And we were using the isRequired property. But what if I were to have a nullable reference type, but would say isRequired? That's kind of disjoint that doesn't really make sense. So we introduced an analyzer via static code analysis that produces a warning if we have a data member where isRequired is true, but it's annotated as being nullable, which is a bit ambiguous. And likewise, if isRequired is false, and it was not annotated, and therefore not nullable, also producing a warning because that's a little bit ambiguous. So we could now, again, when we take a look at this code, we could now also take a look of how Roslyn is seeing it. So how does the compiler see nullable reference types? If we take a look here at this string, we see this is the syntax tree. This entire document is a tree that consists of syntax, nodes, and tokens, and also trivia, where trivia is something that is not compiler, that is not relevant for IL code. So like comments are trivia. We have tokens. Tokens are terminal, so they are leaves in those trees. And nodes are elements in this tree that have children. And when we take a look at the string here, we see this entire thing. That's the method declaration. In this method declaration, we see, for example, a token called public keyword. We get all the information, all this entire source code in this tree. We see there is a parameter list with with 2 parameters. And one of these parameters has as type a predefined type, because we use string. That's a language keyword. It's a predefined type. If we were to add a question mark, now this predefined type is wrapped in a nullable type. So if we now search we can now search if this parameter types is a nullable type or not, and then check it with this data contract isRequired attribute. And if there's a disjoint, then we produce a warning. And the cool thing is with Roslyn, you can also provide not only a so-called analyzer, where it is, there it is, diagnostic analyzer. You can also produce a code fix provider. And this is what enables this Alt-Enter or Control-Dot experience to fix code automatically. Let's say I say isRequired false, but I didn't annotate it. Now I get this warning that we produce here with a custom message, and we can hit Alt-Enter and then say change nullable, and this is now adding the question mark so that those 2 annotations are no longer ambiguous. I think that, for example, Entity Framework was using the runtime diagnostics, the runtime analysis of this via the nullability info context to understand which properties are null, so that it understands how to map them, for example, to SQL. So doing a lot of at runtime, they are now more and more switching to compile time created things. That also helps AOT, native AOT, ahead of time compilation a lot. So they analyze the code that you write at compile time, which means at runtime there is no work to be done at runtime because we already did it at compile time, and have saved a lot of performance and could also have native AOT. A lot of tools are going more and more into compile time. Talking about the static flow analysis, how does this static flow analysis work? How does the compiler now emit those nullable warnings? If we are in a nullable warning context and also have nullable annotations enabled. In this case, we have both enabled. How does the compiler do that? We see we have here a type. This type has a string property that is not null, and in one of the constructor we set it, where it also accepts a non-null string here. If I were to do a question mark here, we would get the warning because we were trying to assign something that may be null to something that isn't null. So we can't assign a string question mark to a string. In this example, we now get a warning on this constructor, on the parameterless constructor, because the parameterless constructor does not set this non-nullable property, or the backing field behind it, to be more precise, that is automatically generated by auto properties, to something that is not null. So this constructor is violating this nullable contract. Maybe we can get rid of this constructor, or we could also alternatively make sure that we set it to something. We could say text equals to the string default. Now we don't have any nullable warnings here. And here I'm now calling into my type, calling the instance.length, and it should not throw any exception, but should print the length of default. I have a typo here. Oh, this does not work. I need to follow up on that. I'm not sure what I'm doing wrong here. And we get 7, so that's the 7 characters of default. Now the static flow analysis is quite static. What if I were to invoke the set method up here, where now we set this to null? Well, we get the warning here because this one says we cannot convert a null literal to non-nullable reference type. Text here is not annotated. We assign null to something that's not null. That's a problem. I could be, whenever there is a nullable warning, you can suppress this warning with the question mark. That's the null forgiving operator, or John Skeet always says, I want this to be null, damn it, the damn it operator. Now we don't have any warning, we suppress it, but now we basically have the problem of having a null reference exception again. Because the compiler only does static flow analysis and it doesn't really check the dynamic flow of it. So we do invoke set here, and set does set it to null, but the compiler doesn't check the dynamic flow, only the static flow. And checking here, if this text is not null, we dereference something that is not null, and therefore it's considered safe. So whenever there is a nullable warning, if you suppress it, then be careful about it, because the compiler will trust you when you suppress a nullable warning. It's basically an escape hatch because the static flow analysis is limited, there is no dynamic analysis of it. And if you know better, because this method calls that, and in all the cases you're ensured this cannot be null, then you may suppress these warnings. We still get one warning here. That's not a nullable warning, that's one of the analyzers. It would like to check this type for null. What this analyzer would like me to do is doing a argument null exception dot throw if null, and pass the instance to it. Because this is a public method on a public type. Since it's a public type, there could be another project using this type and calling this method, but this other project may have nullable reference types disabled. Therefore, it's still good practice to still do argument validation via argument null exception on your public methods. For private and internal methods, we really don't need to do that, because those internal and private methods, they can't really be called. Well, they may be called via reflection, but that's a dangerous mode and kind of an unsupported mode anyway. Things may go wrong because we may violate the contract via reflection. So we know that internal methods are only called by things that we control, and if we, for example, have all the nullable warnings as errors, then nothing can be wrong here. But for public methods, it could be invoked by a caller that doesn't have this feature enabled, so it's still good practice to do on public methods, checking if this argument is passed in null, and if it is, then throw. Let's talk about generics. There is an interesting aspect to generics. What we learned in the beginning is that a nullable value type is foundationally different to nullable reference type. They're not really compatible. They syntactically look the same, but at runtime, that's totally different types. One is a different type, the other one is based on annotations. So if we have an unconstrained T, this could be pretty much anything. On the usage example, this could be an integer, this could be a nullable integer, it could be a string, or it could be a nullable string. So nullable or non-nullable value types, nullable or non-nullable reference types. If we don't have any constraint, everything is allowed. There is now, also with C#8, the not null constraint. If we want to ensure that neither nullable value types nor nullable reference types are passed in. So if a word here, I have the not null type that is constrained to not null. If we were to use a nullable value type, we get a warning saying we are violating the not null constraint. Likewise, you have a string of question mark, it's also violating the not null constraint. This is, for example, used by dictionary. If we take a look at the dictionary type, this one is annotated where the key is not null. Because if we were to call the add method with a key that is null, the key flows into this method. And here we do a null check. If the key is null, then we throw an argument null exception. Hence the annotation. So I already know at compile time, if I were to pass in, oops, let's turn it around, let's do string. If I were to pass in two nulls for keys and values, I can annotate my values as null. But if I were to annotate the key as null, we get a warning here, we violate the not null constraint. Because this would now throw here in the add method, we cannot add a null key. Because, well, dictionary that's that hash based, there is no hash to null. A constraint that we already had before is the class constraint. Now when we have nullable reference types enabled, this now means just as a regular string means non-nullable string, a class constraint means non-nullable class. So if we jump down to the usage, we can do a non-nullable string here, but if we were to say, please do nullable, we get a warning, we violate that constraint. If we would like to allow nullable reference types, we can now say here class question mark, which now allows us, we may be having a string question mark here, but we don't have to. We can also do a non-nullable string, which now forces me, of course, the method here cannot pass null because the t is now not null, so I would need to pass in something not null. We before already had the struct constraint. There is no struct question mark constraint because of the foundational difference of what the type is. Because a t struct is different than a t question mark of struct with this nullable type. So there is no struct question mark constraint. And with now a combination of all these question marks and generic constraints, we can annotate all of our types with high fidelity already. But there are still some corner cases where those generic constraints and the question marks just do not suffice. And for that, in .NET Core 3 and later .NET Core 5, I believe, some special nullable attributes were added that are meant to be directly used by the author of these types. We now make a also bit cycle back to the difference between read and write state. For example, what if I had a property where I want to ensure that it's always returning non-null, but setting null could be allowed because I ensure in the code, if this value is null, then I use string empty, and therefore the backing field never really is null. This is where the allow null attribute comes in. If I were to remove this allow null attribute, we get a warning here, because I'm invoking the setter with something that's null, where the type has not been annotated. So we violate the contract. But with that attribute, we now say, well, the getter ensures that it always returns something that is not null, but the setter may receive null, because we ensure here that we indeed don't violate this contract. But again, the compiler is not trusting us, so don't lie to the compiler with these attributes. Ensure this contract. For example, this is used by the HTTP response message. There is a content attribute, and the underlying content field is nullable. Therefore, it's okay to set null to this, but the getter ensures that if content is null, we instead return empty content. So the getter never returns, well, that's also the read state, to come back to the nullability info and nullability context. The read state is not null, but the write state may be null. And we ensure with code, and we help here the static flow analysis, the nullable diagnostics, to produce the correct warnings when it is misused. This also exists in the other direction. What if I would like to have a nullable read state, but disallow null writes? This is where the disallow null attribute comes in. If I were to set null, we throw an argument exception, but we could still return null. So this is when we need those attributes when we have a different read and a different write state. For example, on the equality comparer, the get hash code says disallow null, because we can't get a hash code of something that is null, therefore this cannot be null. For the equals method, it's fine to pass in nulls, because we could compare two nulls to each other. We could compare left is null, but right is not null, or neither is null, but with get hash code, never be null. There's a bunch of more of these attributes. I think like 8 or 10 of these. I have linked the documentation to all of these. There's quite a bit, and you don't need them every day, but when you need them to annotate especially when you have library types that are reused by maybe an entire company or other teams, or it's a NuGet package and then the world is the potential consumer, then they come in extremely handy. I want to show 2 more of these attributes because they are super, super prevalent to use. One is from the dictionary, try get value. This is the very common try pattern where we return a Boolean, in this case, when the Boolean is true, the key was found, and then the value that we receive via the out parameter has been set. If the Boolean is false, that means the key was not found in this dictionary, and the value could be anything. So the value should not be used. And even, in this case, the value could be null. So we here have an annotation, may be null when false. So if this return type is false, then the out here may be null, because in the code we just assign default to it, which means if value was a reference type, default would be null. And from a consumption perspective, if we now get a nullable value here, and although this says question mark, it is safe to dereference here because of this annotation. The compiler sees we dereferenced this nullable value, nullable reference type, if the return type of try get value is true, and via the maybe null when, we now say, in this case, it's safe to dereference because it's the actual string value that we pass in here. But it may be null if it's not. So in the case else, if this boolean is false, then it's not safe. Although we annotated the value here, we haven't annotated the value, so we said this is a non-nullable string. We do get a warning here because of the, maybe null when, we return false, therefore this value may be null. Another really nice attribute is sometimes I do more complex initialization, and maybe I don't initialize my fields in the constructor directly. Because the compiler does the field initialization analysis only in the constructor level. So, for example, I could write code something like this. I have my constructor. I get in a non-nullable string. I set this non-nullable string here, and the contract is fulfilled. If I were to remove this assignment, now we get the warning here because this constructor does not set all of its non-nullable fields to something that isn't null. But what if I were to do this initialization not in the constructor itself, but in a different method? So I'm calling here this initialize method. Well, perhaps we should make this private. Calling this initialize method, and this initialize method now is setting the value. But we still get the warning because the compiler doesn't go into the initialize method and maybe its methods and see are those fields eventually assigned to. But we can help the compiler with the member not null attribute, then saying which fields are not null after this method has been called. And now the warning now went away because we help the compiler when initialize is called, value will not be null. If I were to remove the initialize method, we again get the warning because value is uninitialized. But again, do not lie to the compiler. What if I were to set this to null? Well, we get the warning here, and now I say, I want this to be null. I use the null suppression operator, the null forgiving operator, or the damn it operator. Now we don't get any warning, but if we were to run this code, now this non-nullable string would now contain a null after this object has been constructed. So be mindful with these attributes, but they can be very helpful especially for reusable libraries. But we also use them in our services a lot, and we haven't had a null reference exception in quite some while yet. Well, just recently we had a key not found exception, but it was not a null related problem. All right. There is one more thing I would like to talk about. There is two more things I would like to talk about null. One is, has any one of you used span yet? Or read-only span? Have some of you used the ref keyword or ref read-only and the in keyword? Okay, I won't dive all too deep into this topic because it's separate talk and quite a rabbit hole. But this is a pattern that is coming more and more, and especially with the upcoming C# 14, we will also have more and more support for span and read-only span. So it's more and more becoming a first-class citizen in idiomatic C# code. We could do something like this, or just use a collection initializer. And when we get a span, when we index into a span, let's get the first element, the second element, int second element, we can actually get this as a ref. A ref is, it's not quite a reference variable. For example, when we have a string, then one instance of string, then this is a reference variable pointing to the string or encapsulating the entire string. When we have a ref, this really is a pointer to a single element in memory. So in our case, this ref now really points to this second element. Some APIs do return refs, and when you have a ref that may be null, you can't really do a null check there, or a regular null check there. You would need to do unsafe.isNullRef. Then pass this in as a ref. This is a proper null reference check for ref variables. Should you ever see them in any of your code. They're not too common yet, but things like that may become more common. There is, for example, a method on dictionary Marshall. As the collections Marshall, where we can, in a singular operation, check if to get a reference of this element in this dictionary. So we get this element directly, not a copy of it, but the element directly. And if the key that we ask for it, I would pass in the key here. If this key is not found, then this is returning the null ref. And this is actually produced with unsafe.nullref. For example, let's say our key is string. So this is how you produce a null ref. And if you want to check if it is a null ref, then you use the isNullRef method. Another thing to be careful about is structs, or to be more precise, reference types in structs. Let's say we build our own value type here. So that really encapsulates the value. Struct itself can never be null. But what if this contains a, let's say, a string text? I will make this init only. And actually, let's make it set. Doesn't really matter. We do not get any warning here. If this was a class, we get a warning and saying the default constructor, well, the default constructor that is emitted is a parameterless constructor that doesn't do anything, or zero initializes all the fields, in this case, effectively assigning null to the backing field of this property. So on a class, we do get the nullable warning here, because if we were to initialize this, well, it's still called struct, but this is actually a class. If we were to initialize this, and we were to text dereference, getting the length, dereference this, we again will run into a nasty null reference exception. And the compiler is warning us here. But if we are on a class, on a struct, we don't get this warning. But we still have the same problem. We don't have any warning, but we get a null reference exception. This is because a struct can always have the default value. And the default value is not calling any of our constructors, it's just zero initializing all of the fields in that struct. And in this case, the default of a reference type is null, so we have null here. So there isn't really anything you can do against that. If you have a reference type in your struct, it may be null. That's how it is. So you need to ensure with code, maybe in the getter, ensure that if the backing field is null, then, well, either annotate this as null to be true, because it may be null because a struct can always be default initialized. Or you ensure in the getter that you return null, or you even maybe throw an exception, invalid operation exception. but still avoid the null reference exception. This is very similar to arrays. If I had a string array with 10 elements, I did not null annotate this. And let's say we now get the first element and call the length of the string. We don't have any warning, but I guess it's quite apparent that we create a new string with 10 elements. We do not initialize any of these values, so they are 0 initialized, which for reference types, the default is null, and therefore we run into a null reference exception. So for these struct warnings and those array warnings, well, we don't really get warnings because they would be very, very noisy because they are all over the place. So when you deal with structs and you have reference types in them, and when you manually initialize arrays, then you need to be mindful that you actually fulfill the contract and either properly annotate it, okay, they may be null, or you ensure that in this case I set tell elements to something that is not null. Well, most of the code is now using collection initializers these days. So in this case, with collection initializers, I am safe. Because the compiler understands, well, I'm trying to now initializing an array with length of 3. To the second element, I assign null to it. This won't work. So with manually created arrays and with structs, be mindful when it comes to null reference types. Cool. Coming to the end, how could we adopt nullable reference types for our own project? Let's say we have, I have here a library. I called this oblivious. We have nullable reference types disabled. Well, even lose a language version that doesn't support them yet. So this code has been written without nullability in mind. Nothing is annotated. Everything could be null. Now, if we enable this feature and also set the language version to at least C#8, now I get warnings already. For example, here I get a warning, I'm returning null to something where I promised this isn't null. And well, I have 3 times the same class, but this could now be in all of my code all over the place on different levels. So there is no 2 strategies of how to adopt nullability. You either start in the project to enable nullable, which enables nullable reference types for every document, for every file in this project, then go into every document and say nullable disable. So we haven't really changed anything. If we do this for really, well, actually, let's do this for each and every document. I wrote a little tool that does this automatically, just putting this on top. Now we haven't really changed anything, but if I were to add a new class, and yes, please, would now start to have a small string text field here. Now for new types, I immediately get those nullable warnings. And I can, oops, not this actually because it's undefined. If I were to write a constructor, now we should get the warning that I was expecting the warning that nullable enable, that we do not initialize this field. Interesting. No, this can't be related. Let's turn on the latest what we got, because I'm not entirely certain. We should get, oh, there it is. Not sure why we didn't get it earlier. I need to follow up on it. But now now with this feature enabled, for new documents that we write, we get those nullable warnings, and we can design our code with nullability in mind. Well, all the old code, we disabled the feature. It's still oblivious, but every time we, for example, now touch a document, we could step by step remove, or commit by commit, remove those annotations on the top of the file, and more adopt our code to be null aware. The other strategy is the other way around. So we don't have nullable reference types enabled, we have them disabled. But then whenever I come around a new class that I would like to, or a new document that I would like, that I'm touching now, and I see, let's make this null aware, I could now go ahead and enable this. And with each and every commit, depending on the size of the code base, maybe after a year, now we have nullable enable everywhere. And once we have it everywhere, we can now remove it from everywhere and just enable it on a project level to enable. So this is two strategies where one requires upfront work and then you start adopting. And the second path requires the removing all the annotations and setting on a project level at the end. So that's a preference. My personal preference is with the work upfront, so enable it on a project level, then disable it for each and every existing document, commit that, and then step by step remove those exclusions, in this case disable, because new documents already have nullability in mind, and we don't make our nullable depth even bigger. So we then step by step reduce it until it's all null annotated. And for example, this is also what the .NET team did. The BCL, the entire libraries and all the extension libraries and the ASP.NET Core, that's huge code. This was not null adopted all in on one release. This took several years now for everything to be null annotated. And there's still here and there some problems, like there is one, I have the feeling there is like one nullable annotation that they change, that they fix, like with every release, because there's just a lot of code. Now, the billion-dollar mistake and nullable reference types, they cause a lot of problems. With the nullable reference types feature, we could shift some of these problems that we get late at runtime, maybe in production, already to compile time to give us some hints. But what if we could avoid nullable reference types in the first place? This is where the null object pattern comes in. Well, the null object pattern is similar to nullable value types. A nullable value type can never be null. The name may be misleading. It's sort of, with this has value pattern, it's more of an optionality. A null object, or the null object pattern, you avoid null. You design your type, but never really be null. For example, if I have a for each, and I would do an IEnumerable, enumerable, assigning null here. Let's say I'm in a null oblivious context, nullable disable. And we iterate and print the items to the console. Oops, item. Now, of course, when we hit this for each, the for each tries to get an enumerator out of the IEnumerable, but this IEnumerable is null, and we will hit the null reference exception. So what if we were banning null? We can no longer use the null keyword, so we would need to use something that isn't null, but still doesn't do anything. So we still don't want to really execute this code, because we want to have a null object, something that represents nothing, but isn't null. Well, we could, for example, do enumerable.empty, which is now an empty enumerable. It doesn't, when we hit the for each, nothing is happening. We don't print anything because it's empty. So with that, we don't have null, but still don't have any side effects in our system. A more elaborate example would be the null logger. For example, I have methods or infrastructure that always needs a logger, but in my unit tests, maybe I don't want to really log anything. I don't want to do the work that is involved with logging. So I could so I don't want to pass null as the logger. What if I were to design a null logger, which is now the null object pattern? So we still fulfill the contract, in this case, the iLogger interface. That's the iLogger interface from Microsoft.extensions.logging. We still fulfill the interface where we have a begin scope method, we have the isEnabled, and the log method. Well, the log method does nothing. The isEnabled method needs to return something. So what would be the most nothing to return? False for isEnabled, so it's a disabled logger. And the begin scope, the contract requires an iDisposable to be returned. So again, we shouldn't return null here, but instead we now create ourselves our null disposable. It fulfills the contract, but the dispose does nothing. Now, when we have null object patterns, they usually don't have any state. And when there is no state, then we could do a bit of optimization and use the singleton pattern to only allow the creation of a singular instance, making the constructor private. So we don't initialize or allocate multiple null objects, always reuse the same because there is no state anyway, and we can we don't pay a price for this null objects that we let that we flow through our system, and still we don't need to do any null checks. So we don't do anything and no null checks, we are null safe. Another alternative would be optional types. This optional type, that's very similar to the nullable value type. The only difference is that this isn't constrained to structs only. So we again could have something like this has value value pattern, where in the case of the value maybe refer, so we always need to check for has value. But yeah, in C#, this pattern or this optional pattern is not super fluent yet. We still need to check something, and it's also not very super exhaustive with pattern matching for on. This is where F# has a huge advantage. They avoid null excellently. Maybe with an upcoming C# with discriminated unions and more powerful pattern matching, we could also have more optionals more natively in our language and avoid null and yeah, never have the nasty null reference exceptions, the billion-dollar mistake happening in our production code base. I'm just briefly checking my notes if I forgot anything. I believe I didn't. Now, this presentation is also online, and it has a bit of an interactive mode to it. So if you would like to go through it, you can also then run the code if you'd like to go through these examples at your own pace. You will find the code here in this repository if you would like to take a look at it later on. And now I'm wondering if there are questions that I could answer right away.